Hi, welcome again. We are still working on the goal programming problem. And you can remember in our first lecture, we were able to define objective function. And also we were able to identify a set of constraints. We had constraints for the 5 goals. And then we developed a constraint on the deviations, meaning that deviations cannot be negative, but rather they can be 0 or greater than 0. But also we look at another non-negativity condition, meaning that all the variables must be greater or equal to 0. They cannot be negative. And our final constraint was that variables must be integers. The next step is to implement the model. And so we're going to use Solver to solve the problem. We will organize the model that we have developed as follows. So the company is IRCO, and let me establish the problem data. So here we have data, and then remember we are dealing with increasing the sizes of the conference rooms, and so we have small, and then we have medium, and we have large. And in this case, our data, first of all, we are looking at the square feet, and then we have building cost. That information is important. And so the square footage, if you can check from the information provided, you can see that the square feet footage for the small is 400. And then for the medium, we have 750 feet. And also we have 1050 for the large. So this is what I'm referring to, the 400 square feet, the 750 square feet, and also 1050 square feet conference rooms. And the building costs are 18,000 for each small conference room, 33,000 for the medium, and 45,150 for each large conference room. So let's add this to our building cost. So here we have 18,000, and then we have 33,000, and also we have 150. So the next thing to do is to define goal constraints. And in this case, we have the actual amount, and also we have underachieved, so right here, and then we have overachieved. So we could get the actual amount, however, we can underachieve or overachieve. And these goal constraints are for small, medium, and large. So let me just write here small, medium, and also large. And you can see that the actual amount underachieved or overachieved, it's something that is expected. And so we don't really have information about this. So these are the decisions which you're going to make, and therefore we can just start with zeros. We can go with any amount, but it's good to start with 0, meaning that we haven't done anything yet. However, we will need to know the square feet achieved, and also we will need to know the overall cost. So in this case, for instance, if you see here, we have done nothing for small, medium, and large, and so that means the square feet will obviously be 0. And also for the cost, then that means we haven't done anything, and so the cost will be 0. So now, if we need to find the square feet, we need to apply Excel function, And we will find the square feet for the actual amount and also the cost for the actual amount. And in this case, to find the square feet, we'll use the following Excel function, which is sum product. And the sum product will be the square feet times this required square feet, which are 400, 750, and 1050. So I'll highlight both, meaning that the first thing I did was to highlight this actual amount and put comma sign, and then highlighted this. And so I'll close the bracket and enter. So that will give us the square feet. But also for the cost, we'll do the same thing by applying this the Excel function, which is sum product. And the sum product will be the actual amount, then put the comma sign, and then select the building cost. And if you can close the bracket and enter, then you will see that the cost. And so the underachieved and overachieved in terms of the square feet and the cost is not known, but so in this case we can put zeros. Next, we're going to look at the goal, and we'll be able to identify the goal achieved out of the target value. And our target values, remember, for the small we have 5, and for the medium we have 10, and for the large we have 15. And so we will define the goal achieved in relation to the target value. That is exactly what we have defined in terms of the constraints. And so you can see that the target value is 5. However, we can underachieve or we can also overachieve. And in that case, we can use function for the goal, which will be equal sign, and we will take the actual amount. And with the actual amount, we are going to add the underachieve as that formula shows, and then we will minus overachieve. And so we can enter, and then we can copy this formula for medium and also for the large. And in fact, we will also apply the same formula for the square feet and also for the cost, because you can remember the target value for the square feet is 25,000, and the cost $1 million. Next is the percentage deviation. And for the percentage deviation, we have under and also we have over. Remember, we discussed about the percentage deviation here, where we set our objectives that indifferent will be given 0 and undesirable will be given 1. And so for the first 3 objectives, you can remember that we had underachieved as our undesirable situation. But for the 25 square feet, we found that having more square feet is undesirable, and also having less square feet was as well undesirable. So we don't have indifferent or indifferences for this goal. But for $1 million, we saw that if we overspend, then that will be undesirable. But if we spend less, that is indifferent. So we will define the percentage deviation of under and over by applying the following function, equal sign, and we'll click on the underachieve and divide that by the target value. And so we can enter. And we will copy the formula from the smallest to the largest. We can extend the formula to the square feet and as well as to the cost. We will apply the same function to overachieved, and so we can put equal sign and then click on overachieve divide by the target value, and so that will give us the percentage deviation, and enter. And we can also copy the formula all through to the costs, and we're going to change this to percentage. And so you can go to this section, and instead of general you can click on the percentage. Next, we're going to include the weights, and in this case we'll provide weights for underachieve and also overachieve. So before we identified the weights that we will not provide weights to indifferent, and so we'll give it 0, but undesirable we have 1, and in that case we'll provide weights to the undesirable outcomes. And so in this case, if you can remember, for the first 3 constraints, under were considered undesirable, and also for the square footage, under was undesirable, but for the cost, which is $1 million, spending less was not considered undesirable. So in this case, we'll put 0. Now for overachieved, for the first 3 constraints, overachieved was indifferent, so we'll put 0. But for 25 footage, overachieved was also undesirable, and for spending more than $1 million is undesirable. Finally, we are going to look at the objective. So if you can remember, our objective was to minimize the weighted sum of the deviations. And so you can see we had weights times the percentage deviations for all the constraints. And so in this case, we will use sum product. We can put equal sign and then sum product, where we will take the percentage deviations, and then you can put the comma sign and select the weight, or under and over. And so you can close the bracket, and in this case we can find our objective. So this will be our set cell. Let me use the color, and I will define this color as a set cell. And also we need to depict the variable cells, and our variable cells will be these ones. And so I will use the yellow color, but also I will include this. These are the variable cells, and so I will define that as well. The yellow color will be our variable cells. So now we can apply Solver to solve this problem. So today I'm using my Mac computer. Let me click on the data to see if I have a Solver. I don't have it, and all I have to do is to go to the tools and Excel add-ins, and then I'll add Solver. So I can click OK, and then I can go to the data. Now I have the Solver, and the set objective will be what we have here, or the set cell. So I'll click on this, and then we are not maximizing, but we are minimizing. So I'm going to click on the minimizing, and the next thing is to select the changing values, or the set at the changing variable cells. So here is a little bit tricky because you need to select this. You need to select this, and then you can put the comma sign here, comma sign, and then select these ones. So if you're using Windows, it's easier, but if you're using Mac, it's a little bit tricky. So if you're using Mac, then you can do the following. I'm going to click the changing cell here, and then I'm going to select this, the small to medium for actual amount and underachieve and over. And then I'll put the comma sign, and then I'm going to click on the command key and hold, and then select this. That will be added. You can do the same as I have done if you're using Mac, but for Windows, you can just put the comma sign and select. So that will be okay. And now all we have to do is to add our constraints. So the first constraint will be that the actual amount from small to large, they should be greater or equal to 0. So I will select the actual amount from small to large, and this should be greater or equal to 0. That is the non-negativity condition. And then I will add constraint, and in this case the actual amount should be integer. So I will also select this, and I will change this into integer, and then I will add more information about the integer later. And then I'm going to add another constraint, and that is about the goal. You can see that we have the target value, and so in this case the goal should be equal to the target value. So the goal should be for all of this, so I'll select all of this, and should be equal to the target values. If you can remember also, the deviations should be greater or equal to 0. So I'm going to add that. And I think we are done with the constraints. Let me click OK. You need to make unconstrained variables non-negative, and the algorithm should be the simplex LP, but we need to consider this integer. And so we can go to the options, and within the options we need to we should not ignore the integers, so please make sure that this is not checked. And the integer optimality is the percentage that is allowed or allowed error, and so we can make this 0, and that's okay. If we can check and make sure that everything is included, then you can solve. And so I'm going to solve this problem because I know that I have included everything. And when you solve, make sure that your solution will show this information here, that all constraints and optimality conditions are satisfied. And so you can keep your solver solution. So I'm going to click OK, and these are the results. And you can see all this kind of information. So please do this and let me know if you have this. If not, then you can send me email, or you can call me to let me know so I can work you through to see where you have made mistakes and solve the problem. And so the next thing is for you to be able to explain what you have done here. And you can see that the company will achieve 25,250 square feet, and it will spend a little bit more, not 1 million, but a little bit more to be able to get these 5, 10, and 15 small, medium, and large conference rooms. And you can see that it will overachieve by 1% and 9.73%. And so the here we have our objective.